So I've always had this timer, and I think the largest lunch and learn, it was like, I don't know, 60, 70 people in the room. It was very hard to manage.
Yeah, you want to make sure people don't go over so that everybody gets a chance to talk. The
Yeah.
list. It's just you today, so you can talk as much as you want.
All right.
I never made your lunch and learns at Centene, so I had to come actually work at the same company to get to one of your lunch and learns moments.
That's right. I did like three of them, something like that. Well, you didn't need to attend those guys. You probably could deliver one yourself.
Mm-hmm. Yeah, you're next. You're up next.
Not next time. Like right after Mo stops talking, you're gonna start.
Yeah, right after it, directly.
All right. Looks like we're ready to get going. Yeah, I think now is a good time to start.
Okay. How is my audio? Because that tend to be problematic sometimes. Is it good?
Yeah, you sound fine. I can hear you. Just perfectly
Okay.
clear.
All right. As I said earlier, welcome to Community Office Hours, month of May, year of 2021. This is me practicing slowing down, by the way, so you guys know. Today's topic will be around log stream tips and tricks, or you can call it best practices. Um, I've actually did some research, got some stuff from the docs, some stuff from my own personal experience, some from the support staff, some, just collected as many pieces of things that I would like to share, things that I learned myself. So your mileage might vary. I mean, some of you are like, I know this is boring. Some of you are like, oh, it's the first time I learned about this. It's really geared toward like entry level, intermediate, and some of the elements might be advanced. But all slides, no demos, and because you'll see why it's all slides, because it's really mostly talking. And please interrupt me. I'm trying to control my pace here. So we have an hour, right? 45 minutes, something like that. Yep.
We've got an hour.
Yep. Okay, let's start with architecture and deployment. So things that we can share, things, again, a lot of that stuff is found in the documentation, and I just with some cleanup from my end here. Uh, Worker groups. I've seen people who actually don't really have a good use of worker groups. Worker groups are designed to group the worker nodes together. So separate them by geographical locations, by business unit, by data privacy issue. I had a customer who actually used the route name as a worker group. Okay, it's new to the product, so they don't really know how to use it. So that's one thing to be aware of. So when you use worker groups, just group them by, separate data by worker groups or routes or both. And then again, revolve around business units, data privacy, whatever makes sense to you, but not routes and pipelines. Those are not good names for worker groups. When using when you using worker group to worker group communication, we strongly recommend using TCP JSON. Obviously, you can do other things. HEC, syslog can be a mechanism of transferring data between worker groups or worker nodes. But TCP JSON is our preferred method for the reason listed below. It's performant, well performant. It can support TLS obviously, and with TLS you get compression, a very good compression, and encryption obviously. So it's the choice, the protocol of choice when you do an internal communication is a JSON, TCP JSON. Early days of the product, I think there were like discussions and confusion in the community, which is the best protocol, but I think this is what we settled on. Okay, in the input side, as you guys know, we need to know timestamps, we need to know event breakers, and everything else Splunk really need to know ahead of time so we can do proper extracting of the fields and events. It is critical that you have timestamp in your event. If you don't have it, we'll do it for you. Okay, and or check your timestamps. Sometimes sources have weird timestamping. Sometimes you find timestamp right in the middle, and we don't catch it, and things go out of whack. Just like you'd see in a Splunk world, timestamp is very critical to our operation. For them, for a different reason, because of TIDX and the way they do database, if you will. But for us, it's critical that we can do actually, we time out events and which one comes first, which one comes next, and some statistical analysis. So we really need to know timestamp, and we have to pass it to Splunk or Elasticsearch. So timestamp is something to be very, very careful with and make sure you have it. The same thing with event breaking. You really need to make sure you're doing your event breaking. For those who never tested that, but you know you can actually cut and paste logs or like a text file of some event and paste it or attach it. And that's when you really start seeing the value, or you have to really mess with timestamps versus if you just get it from the stream, you may not notice it because we detect that automatically for you. Just be aware that event breakers and timestamps are very important for us, and you have to have it. Here's a good one. Sizing. If you have a scenario where your destinations are healthy, you can reach them, no problem. And sources are healthy, they can communicate, but they're still queuing data for some reason. So nothing seems to be out of whack, but the sources continue to queue data. This might be an indication that your environment might be undersized. Why would that happen? Okay, and obviously you need to contact support, or SE, just to reevaluate. So when we initially do the sizing exercise with you, we assume we have certain assumptions. And when you go into production, you may actually have the same assumptions valid for a while, but then over time, things will change. The rate of ingestion change, the complexity of your data can change. Tons of things can change. So just be aware when you have this scenario where everything looks good, source is good, destination good, yet I have queuing stuff on the source, that could be a sizing issue of the environment. Number 5, I got alerted to this one by one of my colleagues, Brendan, if you guys know him. And he actually, we're troubleshooting an issue with a customer, and we're scratching our heads. And it ended up being the time sync between worker nodes and the leader or the master. So make sure you have NTP enabled in all the worker nodes and on the master, or i.e. leader. So that's it throw things out of whack, things to be out of sync. So it's very important you have a synchronized clock between those servers. Something like this, I would never, guess unless you go through it. So in the field. Okay, let's talk about routes. How do we avoid route creep? Again, this is a general data manipulation recommendation. Again, you see the same thing in Splunk, the same thing in Elastic World. You're trying to minimize and reduce the amount of data as much as possible. Just like in Splunk's SPL, you want to do the first pipeline, get bulk of the data, filter it, and then move on to next pipelines. Same thing here. When you're pushing things through your routes, you want to reduce the volume of events as much as possible. So subsequent routes will have less data to deal with. The intention here is to enhance performance. Functions, the same way. If you're doing any, not exactly the same way, but if you do any cloning of the function, if you want to clone the data while you're processing your functions, you want to clone the data as late as possible in the flow. So you want to minimize the number of functions acting on this data. So the later you clone the data, the better off you are. And in terms of route, the earlier you reduce the data, the better off you are. Again, those are tips around optimizing performance. Again, if you have a low volume data, low ingestion rate, it's not a big deal. It's really, those things really show at a high rates of ingestion. And I hate to use the word 10 terabytes a day. It's really how many events per second, really. That's really what matters. But it's the ingestion rate that really matters in cases like this. Number 3 is, let's go without explaining, is just always create a catch-all route. You may have the perfect pipelines, perfect routes created, and then the 99% they work, and this 1% that doesn't work. You really want to have catch-all route, just like in the Splunk days, you'd have a default route the default index or main index. The same thing here. You want to have a route that catch the things that may have filtered through. So just common good practice. Pipelines and functions again. I think I have 2 slides on that one. Do not overload your pipelines. What does that mean? As you guys know, and we have a slide on that, we have pre-processing, then the pipelines and routes, and post-processing pipelines. So there are a usage for each one of them. Some people tend to lump them together, and they use the post-processing and pre-processing in the same area, the same spot. You want to avoid doing that. It makes troubleshooting difficult. You have to really be able to isolate the problem. I got the event, I pre-processed it, added metadata, then I did my own pipelines onto it, and then I may or may not have post-processing pipelines. So I want to be able to see which part of my event got messed up by which pipeline. The more you separate, the better off you are. Good so far? I'm checking, take a breather here. Another common one, number 2. When do I use extract? I'm sorry, when do I use regex? When do I use parser? They both do the same function. Parser obviously tend to be larger and bigger, so you can just kind of extract a bunch of files, the same bunch of fields at the same time. But regexes tend to be laser sharp, like specific to a specific field. So if you have a need to handle few fields, regex is the best route. If you have a need to extract a bunch of fields, then definitely the parser is. Again, the intention here, do not create a parser function just because you want one field only and then rename it or redact it or do whatever you want with it. So it's not really very efficient use of the environment. Does that one make sense, guys? I'm assuming yes.
That's a really good one. I struggle with when to use which function as well. So that explanation helps.
Hey, I got a winner. Okay, group functions for the number 3 and 4 are really common sense, but you guys may know, and most of you are seniors here, so we can group functions together, and it has no impact on the way we process data. It's just to make it easy for the visibility, visual context, if you will. So practice that. Dave Maslin is good at that. He's always like grouping things more than I would want to. Again, if you don't have a huge pipeline or like a huge number of pipelines or functions, I should say, don't overburden yourself with grouping. It's only when your functions list grows to be too much and you can't fit them on one screen and you can logically group them together, that's really what you should be doing at this point. Again, has no bearing on the functionality or the sequence of events or anything like that or performance. It's just the visual appearance thing. Comments? I am guilty as charged with this one. It's you have to practice good coding, programming, commenting, and things that you can put in a comment. Just your name, when you created this thing, what is the sample file you use? That's like such a simple thing. You have an environment with much of sample files. I can attach my pipeline comment to the sample file I use. So this way I have too many sample files and few pipelines. Now I know which sample files to apply to this function. Something simple like this throw you off. I end up like, this pipeline is in Palo Alto archive and this, sample file Palo Alto, they must be the same. So save yourself a headache, your users a headache, and just use something that makes sense in terms of documenting the pipelines. Again, no impact on functionality is just as good practice. I know Eugene does quite a bit of that, right, Eugene? Trying to get you to talk. All right, so here's another good one. If you have a source that supports metadata, like index type, source type, host name, whatever, some metadata comes with the event itself, you have the options to override it. Elastic Beats agent, for example, they have metadata called index in the event itself. I don't like the way the index is called, and it's coming as the word firewall, and when I call Cisco ASA, I can do that. You can do this in a pre-processing pipeline. So remember, you have that option to overwrite meta field data as they come natively from the source. 6 is a good one. And again, I am guilty as charged here. I practice this all the time. I don't even practice what I preach here. And a lot of times when I'm processing a underscore raw, I end up creating temp field, temp storage area, and I call it message, and then just do everything there and just put it back into raw. That is a bad practice. It's from troubleshooting perspective, when you're creating the route, the pipeline, that's fine. But what you need to do is actually, what you should be doing is, I have a feedback. What you should be doing is actually process the events inside raw as much as possible and avoid using temporary storage. Remember, I can't see the recipient.
Okay, Mo, I muted it. All good.
Okay. Yeah, thank you. So it might be insignificant, but remember, you have a large volume of data coming in very fast, and let's say the event size, I don't know, 1K, 800 bytes, whatever it is, and you're constantly duplicating that. You're effectively inside the product duplicating the size of the data ingestion. If you have 1 gig worth of traffic, you're dealing with 2 gigs now. Obviously, we're memory and CPU bound, so this will impact your memory. We assign 2 gigs, we'll discuss that later, 2 gigs by default to each worker process, not worker node. and you may end up consuming your memory quickly here, and you don't even realize why am I using so much memory. So practices like this can optimize your memory usage. So 7, that's a good one too. If you're using persistent queue, called PQ, we strongly recommend that you configure it in the UI. There's a way to configure it to use smaller file sizes versus larger file sizes. I think the default is set to 2 megs. I could be wrong there, but the smaller the files are, the more efficient the processing is. I need to take a break a little bit. Does that make sense, guys? The number 7. Anybody had a comment on that? Anybody using that?
So how much smaller? Like 5 bytes? No.
No, it's actually telling you do not make it bigger. That's what it's saying to you.
Ah, okay.
I say that don't say make. Oh, I'm gonna make 1 gig file. It's easier. I can read it to one time. Just say no. Stick with the default. Default is probably good. If you have
Okay.
performance issue, reduce it to further. So. And number 8, we recommend this over and over and over. You know, and always a good practice because we only keep logs, and the monitoring screen, if you will, only keeps log for 24 hours. If you want to do some trending analysis, it's best to just kind of bounce those logs to a metrics engine like Kafka, you know, Elasticsearch, whatever. So, not Kafka, I'm sorry, Grafana. We have, if those who don't know, my esteemed colleague Dave Maislin wrote an app, Splunk app, and you should check it out. It's really cool, and it just consumes your metrics logs from Logstream into Splunk and just give you long-term trending analysis. So it's kind of cool. So you'll find after you deploy the product, once you build it and you send everything to it, it's like the volume and the rates and the loads are kind of stable for the most part. They don't just kind of spike all of a sudden unless there's a problem, you know, DOS attack, for example. So you need to be able to spot these things. And when I say monitoring, it doesn't have to be a traffic volume. It could be CPU consumption. I mean, like if all the worker nodes are like 60% CPU and this guy is like only 10%, why? You know, I need to know things like that. So, and that's probably indication of improper load balancing and the ingestion side. So good practice to send those logs externally to another analysis solution. Okay, that's a good one. If you have a expression, a value expression like employee.length, for example, the length part is called property in JavaScript lingo. So if this variable itself, if it's not null, if it's undefined, if it's empty, then the property is invalid. You cannot really use it. So if you're trying to do comparison, and I use loosely this comparison, that's not how you do it in the UI. I said len equals something, but that's how you do UI. But if you're trying to assign a variable length of employee ID length, if the employee ID is not defined, then its property is also undefined, and I don't know what's going to happen, but I think it will not calculate, and things will not come out as expected. You'll be scratching your head. I'm using the length, but by the way, employee ID doesn't even exist. That field's not even extracted. That kind of stuff. So,
Are you saying that won't be like truthy or falsy? It'll just be invalid?
I don't think it's defined. I think you don't even know what to expect at this point.
Okay.
Yeah.
Something to test. Thank you.
Yeah. You need to. I think it'll probably change in behavior too. So, if I'm not mistaken. They give you an example in the second line. You know, if the field doesn't exist or undefined, again, you're doing comparison. And the stuff in the green, it says employee ID underscore length. I'm sorry, that length greater than 10, and the same thing less than 10, and they both will evaluate to false. So the first one is different than the second, by the way. The first one was going to be unknown results. The second one that actually answer your questions, it will default to false all the time, even though they look different, but they will evaluate to false. Okay, I should be doing quiz in this one because I've been asked this a million times, and I made sure I capture it here. What's the difference between double equals and triple equal? You know, and there's no way for me to cover it now, but too late. But equal is, as the name implies, equal, just like single equal. Triple equal implies that both sides of the equation have the same type. Double equal means they have the same type. No, I'm sorry. Just double equal, they don't have to be same type. triple equal have to be the same type. That's why if you look at the second line where it says, where it's highlighted in yellow, integer 5 and string 5, they are not the same. Most of the time, you're not going to be doing triple equal. I barely see that, but just remember it's there for you to be used. But if you're using the common one, double equal, make sure both sides are the same type, integer, string, float, whatever it is. So the standard Java expressions practice. Questions so far? Okay, I've always known we can do if then else, but I didn't know it was called ternary operator. That was a new thing I learned actually. And for those who don't know, you can do if then else statements inside Cribl log stream. And the stuff in the green, it says here, if the age is over 18, if it's true, then the expression will be adult. I'm sorry. If it's true, it will be adult. If it's false, it will be minor. That kind of. I'm sorry. If it's true, it will be adult. If it's false, it will be minor. So just remember that you have that option into doing if then else statements inside logstream. This is the inherent power of Java scripting.
Where's the else in that one? Can you do else's in that?
If then else. So if age 18, then adult, else minor.
Oh, okay, there you go.
Yep. I should have actually, that's a good idea. It's probably easier to describe it the way, write it the way I describe it.
And you can
Yeah, question mark is this, colon is that kind of thing.
Yeah. It's just, this is a common practice in a lot of languages, by the way. They're trying to optimize. It's really, I don't like it, but it's good for compilers, really. So JavaScript is following through. Just remember that. I think, I don't know, Splunk has if then else, but I'm not sure they use same syntax here. So
No, it was different in Splunk.
yeah, different syntax. Yeah. Number 5. That's a good one. And I've seen this question get asked over and over and over. I have an expression, and the field name has non-alphanumeric. The @ sign, the underscore, the dash, the dot. If you have cases like this, the fix is have a single quote around that expression or that value. And this is how you can address that. I mean, user agents is very, very common. I've never seen fields with spaces, but if they do, then you need to have some field names, I should say. You need to have a single quote around them. Always gets a lot of people. It still gets me until now when I'm tired and I don't know what I'm doing sometimes, and just like, it's such a simple thing. Okay, this is, I really changed the position of this slide like last minute, right, like half an hour before here, because it helps understand or explain these subsequent slides after that. But those are the capture point in the product. And let's start from the left. You have the source, and this is what the event is going through when it's trying to be processed. The first thing the event hits is the custom command. If you have it, then we're actually going to execute that and just see what impact it's going to have on us. Then next thing we're going to do is we're going to apply event break-in and then extract the meta fields, if you will. Not extracting, but identifying the meta fields. Those are the 3 things you don't control. It just happens. You know what I mean? Then we apply the pre-processing pipeline, which is optional. Then we go to the main core engine, which is routes and pipelines, which is what most people are going to be doing all the work. And then obviously the last stage is the post-processing, optional again. Most people don't really use it. I haven't seen it. Maybe it's been used more than I think, but the numbers you see is where we can do sniffing, and I keep using this word sniffing loosely, or capture. I love the word sniffing because it comes natural to me. So, but this is where you can actually capture events before and after the optional pipelines, and it's a good way to troubleshoot what's happening in your events while it's trying to transform it slowly. Good spots in the product where you need to see how is my pipelines impacting my event transformation. Question becomes, what other sniffing options do I have? Or capture options. At this point, you can do it outside the product with TCP dump. And I've had like a magnifying glass on the sources and magnifying glasses on destination. Great tool to just quickly see event comes in, and if the event is in clear text, you can actually see the event when it came in the system and the event exited the system without even looking at log stream. So Log stream is like a black box for you, and just sniff on the incoming traffic, sniff on the outgoing traffic, and you can truly see what happens to the event, and you see the impact of log stream. Additional troubleshooting step. So you're not bound for what's in the product. You can actually do it on the in the OS level itself. Does that make sense, guys?
Yeah, I I actually had a question that slide reminded me of. You mentioned overriding metadata in the pre-processing pipeline.
Mhm.
You could do that in any pipeline. I mean, is there a reason to do it in pre-processing over in just a normal pipeline, or is it just, is there any
That's a good
difference there?
Yeah.
Yeah.
Yeah, I'm gonna guess. I'm not the expert at this point, but my guess would be it's for speed and performance. You're right. You can do it in the main section of the product, but
Mhm.
you want to condition that event as much as possible to simplify your own actual real pipelines.
Okay.
So
I like
if
that.
your event doesn't, yeah, if your event doesn't have a source type, for example, and your routes, all of them have source type as a way to pinpoint the data, instead of just trying to have another, line, run a function to add the data, just assume it has pipeline, assume it has a source type, and the way the trick is, you know, with through pre-processing. Just I think it's a cleaner way to do things versus and may not be performance related actually, just cleaner way of doing things. Unless anybody have different opinions, I'm willing to listen.
That's good enough for me. I like cleaner.
Okay, and the reason I put this slide ahead of the last one here, which is this was not the last one, is actually to tell you when you troubleshoot things, good practice is to start from right to left. This is a good practice. You start with destinations and make sure you have a process listening, make sure that you have whatever things that are working, and make sure data actually may or may not be reached. Then you go backward through the sniffing points or the capture points in your troubleshooting. This is a good practice. Start from right to left, destination, pre-process, post-processing, actual pipelines en route, pre-processing, and then the rest of it. So unless now, again, common sense, if you know the source doesn't really send data from the get-go, don't start from destination. I know my source doesn't work, so I'm gonna troubleshoot this one. So, but this happens when you have like a system that's working, it's been working for a while, and all of a sudden something is wrong. So that's what I would start destination. But again, practice common sense and use the discretion. This is for the newbies to the product, and I don't have the list here, but maybe we have someone who's new. The sources have three categories: push, pull, and internal. Pull, as the name implies, it can come from S3, it can come from Kinesis, Kafka, and that means that we, Logstream, the worker nodes, will actually actively chunk the data to pieces and just assign it to each worker node and just pull the data in. That's called pull-based sources. Push is, as the name implies, can be TCP, can be syslog sending stuff to us, any agent-based sending things to us. And then the last one is internal. This may not be clear to a lot of people. We actually can generate data internally through DataGen. Clint, our founder, was the primary driver behind GoGen, which is the next generation of DataGen. Nevertheless, as you guys know, that we can actually import a sample file, run DataGen, and just have simulated traffic. So that will be an internally generated source. From the destination perspective, we have streaming types. Streaming meaning things need to be in real time, like Splunk, syslog, all near real time. Nothing's real time. But then you have non-streaming stuff, again, like S3, you're sending things to NFS, something like that. So we can tolerate delay and those streams. Then we have the output router. Output router, for those who haven't used it, it's a neat trick. You go in the UI, you go destination, and you pick up output router, and then you can apply rules. How do you want to route your traffic? So you're sending things to multiple destinations based on rules, like detecting index name or something like that. So you can do it in the main pipeline and the main interface routing pipeline, but it's also easier if you have a quick and dirty thing. I'm going to use output router, apply a few simple rules, and then based on that, if your index name is firewall, go to that direction. If your index name is IDS, go to that direction, that kind of stuff. And dev null, I don't know what it is for. Anybody knows? I'm trying to make
Yeah.
it. What is
Dev
it?
null would be throwing something away, so Linux garbage can.
You failed the class. This wasn't a question. This was not a question. Okay. I am a visualization kind of guy. So I love workflows and things like that. And I try to, when I started doing this thing, it was like spaghetti like, you know, so over time, iteration, I ask a lot of people. So trying to simplify a decision making process when it comes to troubleshooting. And I know it doesn't catch all the scenarios. So I was very specific in this scenario. My destination is not receiving data. And you can poke holes in this all day long, by the way. But I want to capture some easy to follow way to when to use the external tools and internal tools. That's really the main core reason that I did this diagram. So destination doesn't have any data. Well, I'm going to look at the live capture from source. Well, yep, data is flowing. I'm going to check the destination. I'm sorry. Yeah, I'm going to look at destination. Is it healthy? Yep, I can connect to it and everything else. No, it's not healthy. Well, what do I do next? So the first stage of troubleshooting, and everybody has a different style. For me personally, I immediately jump to outside Cribl log stream. I go to the OS level. So when I do things like Telnet, Netcat, TCP dump, Grip, all the good tools that you guys are familiar with. In my opinion, TCP dump trump them all. It's like the king of troubleshooting when it comes to connectivity, and then come netstat after that. LSOF, for those who are not familiar with it, list open files. It's a common Linux command, or Unix, I'm sorry. And basically everything in Unix is a file descriptor. A socket is a file descriptor. A file is a file descriptor. Everything Unix does, it will assign an FD to it, a file descriptor. So when you say list open OF and grep for Cribl, you'll see all the sockets, all the queues, everything else around log stream. Loggen. Anybody knows what that is? Most people don't. That's a $10 gift for that. Don't Google it. Okay. I figured nobody knows it except me for some reason. I don't know why. I've managed syslog-ng for quite a while, so I'm very familiar with it. Loggen is a tool, a utility that gets shipped with, written by syslog-ng folks. So if you want it, get syslog-ng, compile it, throw syslog-ng, and keep that tool. It's really nice. Basically, it's a command line tool. You can simulate a syslog without having a syslog. And I'll show you an example of how to use it. We say loggen, you give it a sample file, you give it port destination, and all of a sudden it will start sending things in the TCP protocol, in the syslog protocol to some destination. So I can test my configuration in Logstream by sending this fake syslog traffic to me, but it is truly syslog native traffic versus NCAT. Netcat is not going to follow the syslog protocol. So a good tool to use. Load balancing, and this is one of the areas where I tell people trust but verify. I had a customer where POC, and things were going fine. Things came from syslog, and they turn on the load balancer, and then traffic doesn't flow anymore, and they would run TCP dump. And all I get from the on log stream size from the F5 was like ACK-sync traffic. Like, where is the actual syslog? Sure enough, we messed with the configuration of syslog-ng. We rerouted things, to go directly to us, and all of a sudden traffic starts flowing. So just because you have very smart people in network side and they know their stuff, doesn't mean mistakes don't happen. So just don't assume, like traditionally speaking, network gear is solid proof, no misconfiguration. Yes, stuff happens, so trust but verify. SE Linux, not a common problem at all, but I've seen it every once in a while. SE Linux and Red Hat get shipped with permissive mode set. If you have a sysadmin who actually like to turn on, and just make sure that it's not just something to check in the process of troubleshooting. And if you can turn it off temporarily to see if it makes a difference, please do so. But one area is not very common, but it's something I would definitely recommend that you checking when you especially doing first install. And obviously the obvious host-based firewalls or network-based firewalls, those are areas you want to check too. Systemd, it's another area. Those are all OS-related troubleshooting. Let's say you got it working, everything is fine. Next stage is to look at the log stream configuration. What should I look for when things don't work? We have sample here. So check for typos, very common. Extra dot in IP address, I don't know. 3 octet in IP address, something like that. 4 octet. But passwords, that's a common area of just little simple typos. Sometimes when you're creating your pipelines, you send traffic to the wrong index in Splunk side, or you don't have the underscore time, it's missing. So permissions, when I say permissions, when you try to start log stream and non-privileged port and you have non-privileged user ID and all of a sudden 514 is not allowed. So that's a permission issue. It could be also file permission issue. It could be permission issues in the receiving end. So like a million reasons where permission actually applies here. This one area to check for. And your logs of your friends at this point, either var logs messages or Cribl logs. Authentication keys and tokens and API keys, another common area of misconfiguration and mistyping. Certificates, and that's normally very tough to troubleshoot, log stream or otherwise, but check the error logs, check the API logs, and that gives you some insights to where the error messages are when it comes to SSL certificates issues. Proxy. Again, if you are using proxy, but there's different proxy settings and environments. You can do a passive proxy where your agents, your desktops, your laptops are not aware of it. You don't even have to configure them in the UI in the browser. That's not what we're talking about here. We're talking about if you have to go manually on your browser and said set proxy environmental variable. If that's the case in your environment, then you need to tell us by setting the same variable. We need to know. Otherwise, we cannot communicate externally, at least to the internet. And if everything checks okay, then now you go to the real work, which means what's wrong with my pipelines and routes. If all fails, you can always, contact the Slack community, very active community. Most of you probably been through it. And it gets answered by a lot of people, SEs, support, developers, founders, so other users. And we can run a diag command actually, and just when you call support, they will ask for diag command. So far, so good. Here's an example of syntax around the tools. Again, this might be simple to a lot of you. I just want to draw your attention to LDAP search. That's one way to troubleshoot LDAP connectivity and authentication piece outside log stream. So everything here, you see outside log stream, outside log stream. So if I have a tool that can verify what I'm trying to do, then I turn my attention to log stream process elimination, basically. Login, I've talked about earlier, and all you have to do is just give it the source, the destination IP of your syslog box and your port, and then a sample file. You want to make sure that sample file is large enough so it runs for a while. And by the way, log stream has other switches. You can specify the rate and the bias, a bunch of things, but this is the simplest form you can do to simulate syslog traffic without having to have a syslog source or syslog engine. Extremely handy tool, rarely used for some reason. Stress command, and I bet you most of you haven't heard of that command, and I've never heard it myself, unless I had a need to. I was building Splunk in a box, if some of you know, and I'm like, how do I test what happens to my application when the CPU is high and load average is high? So I wanted a tool, so naturally start Googling, and I find this command. It's an awesome command. You can simulate stress on your OS. So you'd say, I want to see what happens to log stream when the load average is extremely high and all the CPUs are taken, all the memory is used. So with a command like this, you can actually simulate that, run the command. There's a timeout. Luckily, there's a timeout. Otherwise, you'll crash your OS. But you run it, and then you start seeing all the numbers going high, and then you want to observe your log stream or any other application for that matter. How does it behave under this load? You simulated a fake load on the OS perspective, which bleeds actually to the application. So remember that command, especially for those who ask for stress testing. I don't think it does load testing around traffic. It's just CPU and memory and load average. Back pressure. Again, everybody knows PQ and drop. Block. The question is, how does block really work? So from TCP days, I did a bunch of programming in TCP and coding when I was young and innocent. But now that I'm old and I'm forgetful, I forgot everything I learned. But the trick is you can set that the window size, TCP window size, and that's what we do. When we want to signal the source that we cannot handle more traffic, please block it. So what you do is we signal the stack, the TCP stack, to signal, this go downward in the stream and the stack, and then we set the window size, or TCP window size, to 0, which means TCP communication will cease to exist. That's just the nature of TCP communication. They always negotiate window size, and sometimes it's changing, sliding window, sometimes it's not. But if one of them, at least the sending side, the receiving side, set it to 0, it's still in the source, the client. I can't take any more. My buffer is full. And actually designed for buffer control in the TCP stack world. That's what designed for it. But we take advantage of it to actually signal the sending side. We cannot take traffic because our destination is down. So. Cool beans, 15 minutes to go. Things to be aware of around PQ. And some of it is common sense, some of it may not be clear. Really, PQ is not designed for application failure. If log stream is going to crash, PQ is not going to help you. That's not what it's designed for. If you have a hardware failure, drive failure, corruption, PQ is not going to help you. Really, this is not the intention behind the product. So, the other one, number 2. I'm going to read this. Engaged, the PQ is engaged only when all receivers of that output exert blocking. What does that mean? Let's say my destination is a Splunk indexing tier. I have 10 indexers. 9 of them is down, and 1 is up. PQ will not engage. They'll all have to die before PQ get engaged. Just remember that when you have multiple receivers as one unit, all of them has to die before persistent queue is engaged. And when it's engaged, by the way, first it hits the memory and it'll build up, then it hits the disk. So if you have a lot of memory in your environment, I have customers with like 96 gigs in their worker nodes. Don't know why, but they did. So it will just build up that memory queue. So the reason we use memory, because sometimes you have intermittent connections, disconnections, and we want to be able to handle those without hitting the disk. So it's this optimization feature. Okay. The same thing with draining. So drain when the last one receiver can accept data. So if you trying to drain the queue and you have 10 of them, as long as you have one of them, at least one of them can communicate, then draining will continue. So just remember that when you have a destination defined as one unit, all elements of that unit has to be offline. Clear? Clear. Okay, doing good with time. CPU resource utilization, extra material, and this is strictly came from our support staff, and things like, just because you have high CPU and your worker nodes, does that mean it's a bad thing? We are CPU intensive. If you have 4 worker nodes and 2 of them are 100%, and the other one's 9%, it's not, well, 90% I'll be concerned, but 60, 70, 50, that's good, which means you're taking advantage of your hardware. Just remember, expect to see high CPU numbers. Not too high, but high enough. And I think the number I've seen here is 60%. So just be aware of that. Some people freak out, oh, my CPU at 30%, it's okay. And then you have multiple vCPUs and you can have few of them at 100% and the other ones is idling. So,
hey Mo, on that topic, do you should customers plan for X amount of overhead on their CPU? And if so, what numbers do you recommend people stay under?
Yeah, I mean overhead, I would stay under 70. That's my personal feelings. But when I say 70, all of them, not just like the entire CPU count, because it depends on the number of vCPUs. So some of them might get hit 100 before the others. So you want the average number of CPUs utilization to be under 70.
Thanks.
That'll be my recommendation. So as the line explains here, so high load is not a problem. High CPU and high load average. So load average, as you guys might know, is not just CPU. Load average includes I/O and CPU and memory. So all these things make up the word load average. CPU is a subset of it. So just be aware of that difference. What else? Yeah. So imagine if you have, again, 4 worker nodes and you see all of them at 90% except one guy, 10%. I will be scratching my head. Why is that? That is an indication of improper load balancing on the ingestion side. in ideal world, you should see all CPUs running in the same level, close to 5-10% difference. So just be aware of that. And then the best practices, and this is just typical recommendation for anybody who's using regexing, like avoid greedy expressions, use literal instead, drop as much data as possible as soon as possible. This all the common things you see around regex recommendation. The last one is something was new to me actually, and I had to kind of research it a little bit. It says high cardinality metrics fields will impact CPU, and I had to figure out what does cardinality means, and everybody has a different opinion. But to justify it, the way my understanding is the number of unique fields in case of like in database world. So the more unique fields you have in your event, the higher the CPU impact. Now someone might ask, what does that mean? I really don't know. At what point do you say, well, yeah, this is highly irregular data or high cardinality data or very randomized, therefore it will consume more CPU than other data that's very randomized. So that is, I think, the gist of it. We do have a function in the product where you can actually inspect the worker node processes. It is, I don't understand it. I think it's support, probably the only one who understands it, and the developers. But it is a deeper visibility to the functionality of the worker processes, like really, really minute details how each worker process is behaving. So just be aware that functionality is there. You can get to it from the UI, but I guarantee you look at it and like, what does that mean? So it's really meant for deep troubleshooting for developers and support staff. Memory, as we said earlier, everything's memory based on the product. At least it's not. So things that consume your memory, lookups, that's a common one. Some functions like aggregation and suppression, we keep some states, so memory gets consumed here. So be mindful of the lookup file size. That seems to be the problem here, like the GUIP data, like 60 gigs at minimum. So if you have to share this in knowledge bundle, you need to be mindful that it has to be in memory for speed. So you don't want, again, this is a common problem with any system, like Elasticsearch has it, Splunk has it. Larger lookup files becomes an issue. We favor memory over anything else, and when you have large database or large lookup files, it's time for you to look up at external entities like Redis maybe or something like that, or REST API approach. What is a good number for memory? It's subjective. Again, it depends on how much memory you have. Each worker process by default get assigned 2 gigs out of the box. If you have, as I said earlier, some of my customers have like 120 gigs in the worker nodes because they can. So in that case, I will actually expand vertically. I mean, we like to expand horizontally, but if you add in more memory and use more memory, you can expand vertically too. So effectively, you can enhance the capacity of the worker processes by allowing more memory assigned to it. Just remember that that's done in the UI.
So what advantage is having a high RAM? Like you said, each process gets assigned 2 gigs.
Large lookup files. And when we do sizing too, we factor this in. The recommendation to do too many little machines versus too little high-end machines, like vertical versus horizontal. So you want to, because once you have multiple boxes, you have other things. You have number of sockets, number of file descriptors, number of available interface cards. So there are other implication comes around horizontal scaling versus vertical scaling. So you can have very fast machine with top-notch memory, top-notch CPU, but then all of a sudden you're sending more than 1 gig to it, traffic. And we all know, yes, the card advertised as 1 gig process, but effectively you only get half a gig out of that. So most 1 gig traffic NIC cannot do more than 600 megs per second. They can't. There's a lot of overhead from the OS and TCP stack, things like that. So those are the things you can gain. So,
hey Mo,
yeah.
What for lookup files, is it loaded into RAM per worker thread? Or is it duplicated in memory?
I don't know the question to that. Answer the question. I know it's memory based, and when you start up the product, it get loaded into memory. I don't know if it's shared or not. I would assume it would be, but I cannot give you a definitive answer.
Cool, thanks.
Yeah, I mean, otherwise it would be ridiculous because you can have like 20 worker processes and everyone you're using half a gig, the memory is gone. It doesn't make sense. So Bless you, whoever you are. Okay, questions so far? We're almost done. And back to around disk space, just things to be aware of. With PQ, we can use compression, so we also have a minimum configuration of disk space. In the UI, you can set, I must have minimum 5 gig free disk space. And I think the log stream will crash, and someone can correct me on that. If we reach that threshold, it will crash. I don't know, it will lock up or something like that. That's my understanding, but I can be wrong. But remember, there's always a minimum space requirement. Again, Splunk is the same way. You have to have a minimum space requirement. What else I can talk about here? That's really... Yeah, so like in the lookup files, the comment here is very large files, like over 100 meg. That's very large. Very large for who? Is it the average specs that we have, or just like for a machine with like 96 gigs of memory? It may not be very large. We have too many memories. So too much RAM, I should say. Questions so far? Finally, the logs. Logs are useless. Just kidding. They're very, very useful, and we have extensive amount of logging actually. And the more I use the product, the more I discovered, oh, there's a gold mine here. So we have logs for APIs, log for traffic, I mean, for everything. API logs tend to be the number one source our support staff goes to, especially to troubleshoot communication, certificates, errors, things like that. We also, if you use the UI, just like you can do in the CLI, find grip and use egrep and supply a regex to it. We can do the same thing with Java expressions in the UI, and you actually have the power of doing deep searches within the event itself. You can do and, or, if, then, else if you wanted to. All the Java expressions power available to you if you're using the UI to search for logs. Obviously, the time picker, you know what I mean? As I said, each worker process has its own logs. Each worker process, not worker nodes. We have a node and a process under threads, if you will. And each one of those guys, and I used to have a directory name there, but it's gone. It'd be like a /log/worker node and /number, and then the actual logs for that particular process. So just be aware of that. And with that, that concludes my very quick mumbling presentation. Questions?
No questions, Mo, but gold mine of information, man. Thank you for putting that together.
Yeah, nice job, Mo.
Yep. Any concerns? Any things you can think of we didn't cover? Anything we'd like to hear in the future?
Well, we've definitely had a request for you to share your slides, so we'll figure out a way to make that possible. I mean, for now, we can just pin them up in the Slack, but yeah, this is great stuff, definitely.
Okay.
Hey, Mo, I have a question for you.
Sure.
I was multitasking as I was listening, and I was getting, I was trying to have a function running, an eval run like a little JavaScript thing.
Mm-hmm.
And it was obviously erroring out because like on the preview, like the little field that I was trying to get was not popping up, and it was not showing an error either. So is there a way to see, like, if you write some JavaScript in there, is there an error place where it show you an error, or it looks like it just errors out silently and just doesn't add the field to the output?
I would definitely look at the logs. That's one area. If anybody has any feedback in here, but I haven't really pursued something like this, but definitely the logs. Remember, everything we do is also API. So master to worker nodes to worker nodes, everything is API driven. So, and there's a log for that. So potentially you can have something there. So also,
what I ended up doing was like trying the JavaScript somewhere else and cutting and pasting this XML and something else and blah, blah, blah. It would just be much easier to, if the tool gives you like, hey, this XML is not properly formatted or whatever.
Yeah. I cannot comment specifically on that one. We can just take it offline, me and you. But the first thing I would look at is the API logs and error logs. And I was going to suggest that, but you just mentioned it. Is actually use an external tool to test your expression externally, just like you would use the regex. Yeah. So.
Okay. Isn't that button that you press on that takes the JavaScript into its full window for test? Doesn't that work? I've seen that give me the red circle sometimes.
Yeah, so that red circle looks like it validates like syntax.
Yeah.
But if the syntax is okay, but something errors in the back end, it doesn't seem to catch that.
I see.
The example that we mentioned earlier with length, the ID, employee ID length, that's a typical example. It's like you're trying to use a field that doesn't exist, or null, and just trying to access something that's invalid. How does the product behave in that, So those becomes typical troubleshooting stuff with JavaScript, yeah, so.
Yeah, okay, thanks, dude.
Yep. Cool. Any more questions? Rachel, back to you.
Oh, I'm totally not in charge here. Thank you, everyone, for
Eugene
coming.
is in charge, yeah.
Yeah, Eugene is always in charge.
I'm definitely not in charge. I was just unmuting to say that. This one I have no claim over whatsoever, and I have a meeting. So this is awesome. Thank you.